When a SIEM detects malicious activity, whether it's a denial of service attack, a brute force attack, or something else, the response is usually still manual. A SOC analyst has to investigate the alert, confirm if the source IP is malicious, and then request the IP to be blocked from, let's say, a network security team to have the IP blocked on the network perimeter. Now, there isn't something wrong with this process, but it takes time. Someone has to log into the firewall, make the changes, and verify that everything is working as expected. Meanwhile, the malicious traffic is still hitting the network. And when it comes to cybersecurity, every minute matters. The longer an attacker can continue communicating with your environment, the greater the opportunity for additional attacks, lateral movements, or even disturbing your services. And reducing that response time is one of the key goals that any modern security operations center is trying to achieve. So the question is, why are we still doing this the manual way? If the SIEM already detects the threat and we have threat intelligence to help us validate the information we're receiving in our alerts, why can't we just automate the response as well? Threat intelligence gives us additional confidence before we take any action. So instead of blocking every IP that triggers an alert within the environment, we can check whether that IP has a known malicious reputation based on the information that has been collected from the security researchers and other organizations around the world. And that will help us reduce the false positives while also responding quickly when we face real threats. And that's exactly what we're going to do in this demo. So at a high level, we're going to have our SIEM, which is going to detect the attack, and it will trigger an automation workflow. The workflow checks the attacker's IP address against a threat intelligence source like abuse IPDP to decide whether it should be blocked. And if it is, then it automatically updates the firewall and blocks this malicious IP address. The entire process takes seconds without requiring someone to manually review the alert, open the firewall, or create any blocking rules. The analysts can then focus their time on investigating more complex incidents instead of performing these repetitive tasks, and it also helps you reduce the mean time to response from hours or even days to just seconds. Now, in this demo, I'm going to use Wazoo and FortiGate, but you can build the same automation with other common vendors like QRadar, Splunk, Palo Alto, or even Checkpoint. So with that said, let's now jump into our demo. This is the workflow that we're going to work on. We have the first node, which basically receives the alerts from our SIEM. Then we're extracting the details that we need for this workflow, which is basically the attacker's IP address. We're sending that IP to the abuse IPDP to check the abuse confidence score. And if the IP is determined to be malicious, and that's by checking if the abuse confidence score is greater than 80, we will basically get the list of blocked IPs from our FortiGate, and we will check if said IP is already blocked. If the IP is not blocked, then we create the address group, correct the syntax, and add the new IP to the list of blocked IP on our FortiGate firewall. And finally, the last node sends a notification to the security team with full details about the IP address that has been blocked. Then here we have our network topology. So this is the network topology we're going to work with in this demo. We have this DMZ web server, which is going to be the target of our attack in this video. The attack we're going to perform is a SYN flood denial of service attack on the HTTP port of this DMZ web server. The attack will be originated from my Kali Linux machine, and all the traffic would be received by the firewall because we are going to target the public IP of the server that is published by the FortiGate firewall. And we should see information about this attack being reported back to our Wazoo server from our FortiGate firewall. On the firewall side, obviously, we have the network security policies. So over here, we have the policy allowing WAN users to access the DMZ virtual IP, which we can also check over here if we go to the virtual IPs. And right here, we can see the local IP address of the DMZ server and the public IP address, which we can check over here. So right here we have the DMZ web server. It's accessible from this 192.168.100.222, which is basically acting as our public IP in this lab setup because it's in the external WAN subnet. So now let's start our attack scenario. I'm going to open my Kali Linux machine and open the terminal. And here, let's try to ping the IP address of our DMZ server, or the public IP of the DMZ server. And as we can see over here, we can ping. So now we're going to start the attack with sudo hping3, and we'll specify the port 80, which is the HTTP port of our target machine. And we're also going to ask for a SYN flood targeting the public IP of our DMZ web server. And we execute this command, type the username password, and now the attack is ongoing. And if we go back to n8n and execute the workflow, so we can receive the alert that will be generated on our Wazoo server. Now we received the alert, and as we can see over here, it stopped at the point checking if the IP is malicious, and that is because this lab is in a private environment, so the IP address that was sent to abuse IPDP is the private IP address of my Kali Linux machine, which we can check over here. So if I type ifconfig, we can see that the IP address of my Kali machine is 192.168.100.105, which is the same IP we received over here. The IP address that was being attacked, if we check over here in the original alert, we can see the public IP address of our DMZ server, which we have over here in the destination IP address. And the destination port obviously is port 80 for the HTTP access. Now, the reason why this didn't go any further is obviously because this is a private IP, and the abuse confidence score is 0 because there is no private IP that is basically malicious within the database of abuse IPDP. Now, to walk around that and try to get a public IP address that is malicious to show in our traffic, I'm going to use this script over here. So we're basically taking the full log that we received on the Wazoo server from the FortiGate firewall. So basically the same alert that we have over here. If I open this alert over here, we can see the source IP and the destination IP, which is basically the IP of the server. Here we have the full log that we got from the FortiGate. And in this script, what I'm doing is that I'm taking this log and I'm injecting it with a different source IP, which is going to be malicious, and then basically sending this alert to the Wazoo server. That is going to trigger an alert that seems to be coming from the FortiGate, but with a really malicious IP address. So let's go to abuse IPDP. And let's take any IP address that is malicious. So let's check this IP over here. So we're going to take this IP address, go back to the script, and right here in the source IP address, we are going to paste this IP. But before we actually execute this, let's go back to the firewall and log in to see what exactly is this going to do. If we go to the addresses within our firewall, we can see over here we have this blocked IPs address group, and it already has 2 IP addresses that are blocked. So this address group is what we're going to use in the first rule in our firewall to block any traffic that we don't want to receive from any IP address that is a member of this group. What we're going to do in this workflow is to basically get the IP address and add it to this list of blocked IPs in the FortiGate. So we should be able to see that this IP address will be a new IP address that is blocked inside this blocked IPs group. So now let's go back to our workflow and listen for new traffic. And then we're going to go back to the script, copy this alert, and open PowerShell. And right here paste the whole thing, but before that we need to obviously make this workflow listening for traffic. And right here we paste it, and now the workflow should receive the information that is being generated on the Wuzoo server. Now here is the alert, and as we can see, the whole workflow has been successfully completed. And if we go back to the FortiGate and refresh, we should be able to see the new IP address blocked. And right here we have it blocked, which is the same IP that we just copied, 212.227, which is the same IP we have over here. The address object is also created. And if I go to my email inbox, I should be able to see the email that we received through this notification node. So I'll go to my gmail.com. And right here we have IB blocked on FortiGate, thread automatically blocked, and right here we have the alert summary, so the time of the event, the action that was taken, which is blocking this specific malicious IP, which again is the same IP address that we have over here. We also have the abuse confidence, which is 100%, the country which this IP address is from, which is the USA. We also have the ISP and the report for any further information that we would love to look at. So for example, who reported these IP addresses, from which countries was this IP reported. We can see this IP address has been reported from a lot of countries, including France, Canada, and USA. We also have information about this IP being blocked. So we've got the source IP, which is obviously the IP that was blocked itself. Then we have the source port, which is the source port from my machine. And then we have the destination IP, which is the IP address of our DMZ server, or the public IP address of the DMZ server. We also have the destination port 80 for HTTP. We have the ingress and egress port interfaces. And finally, we have the policy action. So this is going to show you if the traffic that was blocked from this source IP was blocked by your firewall or if it was allowed. In our example over here, it shows a server reset because the traffic was not really going to the server. It was just logs that were not going anywhere that I was just sending to the firewall. So you don't really see any action from the firewall. But this is basically going to show you if this traffic from the source IP was being allowed or denied by your firewall. Recommended steps is obviously number one, review the firewall logs for the related activity. So let's do that. Let's go to the forwarded logs. And right here, we are going to set the destination to be the public IP of the server. And here we can see that all this traffic has been sent by my Kali Linux machine, which is the flood traffic that we sent during the attack. If we go back over here, we need to investigate the target endpoint for signs of compromise, verify whether the source IP has attempted connections to other systems, and finally confirm if it's a false positive. If it is, then remove the block from the firewall. So these are good recommendation points to just follow whenever you see a block that happened on your device. But in this scenario, that will not really be required because we do know that the IP that we blocked is a thread IP address, and we can see that from the abuse confidence of 100%, which basically tells us that this is a completely malicious IP address. And that's the great thing in using threat intelligence, because it gives you the confidence when it comes to taking action regarding some IOCs that otherwise you could be unsure in whether you should block them or no. So that's it for this demo. I hope this has been informative. This is a really great setup that can really help your environment. It helps reduce all the manual work that it takes to block malicious IP addresses, especially when they are confirmed to be malicious IPs that could compromise your environment while you're still trying to do the process of blocking the IP manually. This workflow now executed in 3 seconds. So instead of getting your malicious IPs blocked in hours or days, this workflow will help you block it in a matter of seconds. As we can see over here, this only took 3 seconds. So that's it for this video, and I hope it was informative for you, and I will see you in the next video.